Hey there YouTube, this is SJM4306 back with another video. This time, we have a portable, rechargeable soldering iron. This was very kindly sent in by a company called Isotip, and they've been making these for probably, well, almost definitely older than I am. So I'm gonna guess like at least 40, 50 years. This is a very old style, but it's super reliable, and it's used in like a lot of industrial kind of situations, especially like field soldering and that kind of stuff where you don't want to be tied to like a wall outlet. So anywho, they very kindly sent this. They didn't ask me to make a video or anything. They watched my videos and they said that they greatly appreciated me sharing my knowledge, so they wanted to gift this to me. So under no obligation to make this video, but I really wanted to, especially since I did a little research into the company and their other products, and it's right up my alley. I couldn't have asked for like a better, not really sponsor, but yeah, basically a better company to encapsulate what I do, which is basically DIY repair and whatnot. Anywho, I've seen a number of videos. Big Clive has put out a really good video. I will link it down below. He actually shows you how to modify the charger base to make it USB powered. So I might try that myself. We'll see. But anywho, this is the model 7700, which I'm just realizing that you can't really see because of the glare. Maybe, there you go. So model 7700, this guy retails, it comes with the charging base, the soldering iron itself. It has a nickel cadmium battery, and we'll get to a second why that might actually be better than like a nickel metal hydride or especially a lithium ion in this case scenario. But yeah, this guy I believe retail for like 70-ish, 60 or 70 bucks. So it's not particularly cheap. It's not really that expensive though. I would think that the biggest competitor to this, obviously, different scenarios, but would be like the Miniware TS80-ish, whatever. Those rely on like a dedicated power bank, so you're still wired to something. It's not totally wireless. This, once you remove it from the base, you'll see in a sec, it is totally wireless. So yeah, just some specs. It says recharges in 3.5 to 4 hours. This guy, because it has a nickel cadmium battery, it basically trickles all the time. So you're supposed to just leave it on the base, and whenever you need it, you pick it up, and it almost instantly heats up. I think the spec says like within 9 seconds, 10 seconds, it reaches 900 degrees Fahrenheit. So that's definitely hot enough to solder by, and that's actually pretty quick. That's quicker definitely than my hardwired base Radio Shack soldering iron that I use, the digital one. It's way quicker than that. I have to wait like 20 to 30 seconds for it to get up to heat. So this will definitely be very useful. I'm actually going to set this up not on my bench. I'm probably going to mostly use it like just in the field, exactly like it's marketed as. The nickel cadmium battery, those will last pretty much for the lifetime of the product. You can buy replacement ones. They sell them, and they're pretty affordable too. I think it was like 10 or 20 bucks or something, which I'm expecting. I've read people had these irons from like the 80s and that they still work and they take a charge, which you would not get with a lithium ion battery. So they do sell a higher end model, which is like a bit over 100 bucks. I think it was like 130 or something. And that has a lithium iron phosphate battery. So it charges up quicker. It holds more of a charge, so you can do more solder joints per full charge. That one, I believe, is like blue or yellow. I forget, but it has a different color scheme. And I think it might heat up faster. I don't know. But this is the base model, and yeah. So yeah, it says partially recharges in 1-2 hours. Power rating is 25 watts. Clive did a measurement with the tip, the resistance, and back calculating from that. I think he calculated that the battery is pushing like 20 amps peak, which is insane for something this small. So that's another reason why they use nickel cadmium, because how fast it could deliver power is insane. Lithium ion is also pretty insane in terms of how much power it can push and how quickly, but it has other problems. Nickel cadmium, I believe, has like a memory effect problem, so you might not want to use this in like very cold environments. But yeah. Anywho, it does come with, I believe, 2 tips. Yeah, a standard fine tip and a standard heavy duty, like a beveled tip. And yeah, just has some like automotive repairs, arts, crafts, DIY projects. So yeah, soldering iron brazing fun, electrical handiwork, jewelry, industrial maintenance. Yeah, and they come with a ton of tips, and the tips are pretty cheap. Last I checked, they're like $7-8. So I think I'm gonna actually buy a handful of these like micro tips and stuff, so I can actually use this for like tiny soldering. That would be really cool out in the field. This is probably going to, honestly, I'm tempted to just throw it in my backpack and use it as like a field kit sort of thing, because a lot of things I do at work, it's a pain in the butt having to drag the like the wired soldering iron around to especially if I'm working inside of a machine. So this would solve that. If this works really well, then I actually might suggest to my company to buy a handful of these and just keep them on the bench. So this is the first time I'm opening it. Warning, yeah, California can give you cancer, etc., etc. There we go. Ooh, the tips are taped on here. So this company seems to be not like a massive outfit. It seems to be like a pretty small scale, like they hand assemble possibly these. But yeah, we have the 2 tips here. We have, I believe they call this the fine tip. And yeah, it is pretty fine. Compared to my Radio Shack iron, it's a bit beefier. So I like this style tip because it's not so great for doing like through hole stuff, but that's really good for doing like surface mount. So I might actually go ahead and splurge and buy the smaller tipped iron. And here we have, I believe they called this one the heavy duty. There's some, yeah, it looks like they pot these in like I don't know, some kind of ceramic or something. There's some residue here. Once it heats up, that's probably just gonna scrape or burn off. But yeah, we have like the chamfered bit edge. Yeah, cool. Yeah, I think it's like some kind of plaster actually that they're using, because it doesn't adhere super well to the metal, like scrapes off. But yeah, might have to, especially if this is passing a ridiculous amount of current, I might have to just lightly abrade the contacts there until they're shiny. We have the iron itself, which we'll take a look at, and these are actually one thing that Clive brought up. These are super easy to open and modify, and yeah, that's fantastic. There's just 3 screws, no clips. It just opens. It's not glued together or hermetically sealed. And they're really designed so that you can just kind of hot swap the tips out. There's a light bulb while you're soldering, and I thought that was an interesting choice. And it looks like it just sort of press fits in. I think it's like bayonet style. We have the charger pins, and these are just directly connected across the battery. So it's directly charging the battery. It's trickle charging. There's no charging circuitry really to speak of. We have a button that has a lockout that you actually have to twist to use, and you can see it already has some power in it. So that's pretty cool. We have the label, Isotip, quick charge. Yeah, it feels really good. It's like ergonomic. I guess you're supposed to hold it like this. And, but I usually hold my iron pencil style, but it doesn't feel too bad. I would have to kind of turn it to the side there to get my finger on the button, but that doesn't feel bad at all. But yeah, it definitely feels more comfortable if you hold it like this. But anywho, we have that. We have the charging base, which, like I said, no special electronics or anything. There's just going to be a transformer on here. And very old styling. I'm pretty sure all these molds they're using are the exact same molds they've been using for like 20, 30, 40 years. So yeah, it just has some like cardboard here, 2 screws, and some foam so it doesn't slide around on your table. And everything is like super openable. We'll open it in a sec. Yeah. The Clive mod that he ended up doing was he drilled a hole and added an LED so that you know when it's charging there. But yeah, that's actually a really good mechanism. Nice positive click. It just sits in there. You don't have to like align it super well. that's pretty cool. And it looks like we have a manual, which is very boldly printed, easy to read. And all the tips. I think the tips that I want to get, I might want to get the super fine, or maybe the micro soldering tip, I think. I might get a couple. I might get some more like bigger beveled ones for power stuff. Long life ultra fine, maybe. We'll see. I'm probably going to buy like 3 or 4 tips anyway and just keep them in the bag. But yeah, installing tip, place leads over the terminal holes, push inward and upward until the tip is fully seated. To remove, pull straight out. You can also permanently attach them using the screw terminals. And yeah. And the way it is, let me just see how long this cord is. The way it's set up is there's like a ridge here, which is for ergonomics, but also keeps, you can lay this flat on the bench and the tip will be like an inch above the surface. So it won't burn a hole into whatever you're soldering. So that's actually a really good design decision, so that you don't need a separate stand. The cord on this is not super long, so you're going to want the base near a charging outlet. It's like about 2.5, 3 feet maybe. And it's not weighted super much. There's a transformer in here. And so yeah, I have to bend this cord a little bit to get to sit flat. But yeah, it's not like it's weighted or anything. The transformer is predominantly most of the weight inside of here. But yeah, that'll sit just fine. Let's get a tip in here. And I believe, yeah, they also sent me, here you go, a pamphlet. They have a full kit that includes like a different, like a heat shrink. I believe it has like a butane torch to set off the heat shrink, solder sponge, like low melting point solder paste. So yeah, if I were gonna get one, I think this isn't too much more expensive than the base one. I would suggest picking up something like this and keeping this, like, it's very nicely like packaged so that you could take this entire little case around with you, and it has pretty much everything you would need to do work in the field. It even has a tube sealer tip. That's interesting. And yeah, they have a lot of other, there you go. There's the blue one that's a slightly higher end model. Here it says 125 solder tips per full charge. But the way you're supposed to use this is you just set it in the cradle between jobs. So you really shouldn't, I don't think anyone would be using this to solder for like 4 hours straight or whatever. So I don't think you're really ever going to practically get to 125 solder joints before just setting it down for a moment to take a break anyway. Yeah, the blue one does a little bit more joint-wise, and yeah, 1 year full warranty, and I think it's definitely based in the U.S. I forget, somewhere, I want to say Midwest. If I'm wrong, I'll put a correction here. So yeah, absolutely, if I ever have a problem with this, I'll reach right back out to them. And the contact of the company was actually very nice. We talked a little bit. And here you can see they also have butane soldering irons. So that's really cool. So that's really cool. I've never actually used, my friend had a butane iron. I've never actually used one myself. So I might just pick one up just to play around with, maybe the low-end model one, just for fun. Because I have this butane torch that I use for heat shrink, and that works really well. And which they also sell those. And they have silver-bearing low melting point solder paste here. And they have, very interestingly enough, also gone into CO2 drain guns, which will, if you have like an obstruction in your pipes or something, you can use this to blow that out. That's interesting. And yeah, tools worth discovering. If you are interested in checking out more details, isotip.com. Yeah, so let's get a tip in here. They said you put it in an angle, and let's see. Yeah, I can kind of feel there's like a spring or something. I don't know if you have to loosen something or... because it's not actually like clipping to anything as far as I can tell. I have to, I don't know, play around, loosen the screws or something. So put it in an angle and then pull it straight or something along those lines. Yeah, you're gonna need like a really good connection, because if this is passing like 20 amps through these wires, you're gonna want to make sure they're really secured. Let me play around with this. I might have to actually break out the screwdriver and to see exactly how this mechanism works. Okay, figured it out. You have to get the screws kind of to the right level. You can clamp down on them and then you can't remove the tip, but you can also set it so that it's kind of at the right height, and they say put it at an angle and then kind of straighten it out, and then that'll hold it. Maybe a little bit tighter than that. But yeah, then that'll hold it. And you can get these kind of, yeah, you can get to just sort of friction fit there. And yeah, so that's pretty good. And the bevel tip, you could actually put the bevel either way technically, because it's just two leads and symmetrical. Let's get this tip in. That should be good enough. And get some solder. Let me clear off my chair so I can actually sit down. I got the box and everything behind me. Okay, so I have some good old 60/40. Switch this around to the use state, and I guess we'll give this a burl. Turn this on, the light turned on. You can already see smoke coming out. First time I fired this up, so it's probably burning off just like stuff used in manufacture. Yeah, that tinned right away. And apparently you can regulate this, so flux is burning off. Let me just clean this off. So apparently you can regulate this by, you don't have to hold the button the whole time. You just do it till it gets enough heat. And yeah, that looks like that'll do a treat. Just clean the tip a little bit. So yeah, obviously then you're gonna have to wait for this to cool down enough to grab it if I want to change tips. Let me try tinning the other tip. Let's just see how much thermal mass this has. It seems like this tip, unless you're holding it the whole time, as soon as it hits a wet sponge, it doesn't have a super lot of thermal mass. That's why it heats up so quick. It doesn't have a massive amount of thermal mass, so it can change temperature kind of rapidly. So when you release this, if you hit the wet sponge, it'll cool off, you know, pretty quickly. So yeah, you can see there's just that one, and then now it should be, yeah, it's just a little bit warm. Yeah, so that's how it heats up so quickly. Fortunate thing that means is you got to hold the button if you're on like a joint where there's like a large ground plane. You're gonna have to be dumping heat into that to effectively melt the solder. And yeah, put it back on lock. Pull the tip out. Gonna stick the other tip in. Might have to get used to. Seems like this whole screw system thing is a little bit more finicky. I would have hoped that you could just kind of plop the bit in, maybe press down on some tabs or something to, but no, looks like I might need to throw a screwdriver in with this kit. Anywho, put it back to use. Let's tin this tip. There we go. Might want to use these kind of in a well-ventilated area the first time, because it's going to make a bit of smoke there. So, tips tin really well. Yeah, so I think if I'm going to put this in my backpack, I'm going to need a case for it, obviously. And because the tip doesn't cool down absolutely instantly, you might want to put some metal. I might 3D print like a travel case for this. Put some metal. I might want to design like a travel dock, because this, you just need like one. I think it's 2.4 volts. It's 2 series cells, so you need roughly 2 volts at a small trickle current. I might make a 3D printed dock that just like slides over the end, and just like USB to that, so I could use this without having to carry the large dock around. And bonus points if it's USB, so it can charge off of like a standard battery power bank. So yeah, that would be pretty cool. Just cool this down real quick. And in addition to that, I think having a small screwdriver in that kit, just so that you can kind of more easily tighten and loosen these to remove the tip, might make sense. And obviously a holder for multiple tips, of course. So let me dig out something to solder, and we'll do a quick demo. I'll get closer in on the camera so you can get a better view. Okay, so we're going to do a bit of a torture test. I got the beveled larger tip here so I can get more surface contact. I have this board, which I believe came from a video projector, but it's got like big ground plane on these like power transistors. Or these might have been regulators, I don't know. But that should be decently hard enough to solder to, so let's just see if I can get this to flow properly. Maybe. Hopefully that'll help. Okay, let's just hit that guy and see. Make sure that I'm in frame there. So, get some solder on the tip. Yeah, it really does heat up in like a handful of seconds. So just pushing the solder around here. And there we go, yeah. So at least that pad I was able to tin that small area. There's like some flux or something when I desoldered the original part on there, so that's sort of masked off. I wasn't able to push through that. Let's flip this over and see if I can get like this grounding pad. If I can just fill that with solder. So we'll heat this up, get this nice and hot. Yeah, it took solder. And there's a bit of spring to the tip too, so you probably don't want to be pushing this super hard. But yeah, I can feel that this has some thermal mass, so there is some sticking going on. Yeah, this is probably asking a lot for a small handheld iron, because this is quite a large ground plane. I don't know how many layers this board has. It might have 4 layers. But yeah, if you just sort of keep it moving and hold the button the whole time, yeah, it absolutely can reflow the entire pad. And the entire pad is molten at the same time, so that's a good sign. And yeah, so I'm just gonna set that down for a sec. Yeah, absolutely, that was able to heat up more or less the entire pad. Didn't quite get to the corners, but, and I can feel on the other side, it is definitely toasty. So yeah, that has a decent amount of oomph, honestly, for that small of a soldering iron, relatively speaking. But yeah, I do like the touch of the incandescent bulb. I know, given the age of this, I think it's like more quaint to go with incandescent, and probably, honestly, that might last longer long term. I don't know. In like non-ideal conditions, and it is replaceable. It's just a standard incandescent bulb there. And let's just see, how do you, I think you have to like twist while pushing in or something to get this out. Yeah, there you go. Yeah, you have to push a little bit. And yeah, it is bayonet style. And there's just a little spring in there. So yeah, now the hard part's gonna be getting this back in. Okay, gotta twist as I insert. And yeah, there she goes. Not something that you should really ever have to replace often, if at all. It'll probably last the life of the product itself. And if that goes out, I mean, that's just for lighting the general area around the tip. I suppose you could find a LED replacement style one that has like a built-in resistor for this voltage. Or you can make your own, I suppose, with a like a warm white LED would be more appropriate, I would say. So I guess all that is really left is let's tear this open, tear the base open, and see exactly what's inside. I know other people have already done this, but we kind of have to open it ourselves. So I'm just going to take out the tip. So 3 screws. And because of how simple the manufacture is of this, we'll see in a sec what's inside. But there's really not that much to go wrong, and if something does go wrong, it's very obvious what went wrong. So it should be very repairable. So 3 screws, and the whole thing just sort of pops open. There we go. The button is like super simple. I love this button. This will last forever pretty much. It's just a like a retaining washer on a plastic molded part that swivels, and then the molding inside has like a nub. You can see right in there that that falls into a notch that's formed into the casing, and that's what allows you to press the button down when the notch is in the use position. Otherwise, you can't press it down. That's really simple. That's really effective. That'll last forever. There's nothing that can really go wrong other than the plastic disintegrating entirely, which you have bigger problems if that's happening. Anywho, we have the case itself, and this was made, I'm guessing, 13th week of 2024, so like very recent. So they're still pumping these out. That's awesome. We have the switch. The switch itself is just what appears to be a bent piece of I don't know, copper coated steel or something, probably, because it is a bit springy. I don't think it's just pure copper. Maybe it is. I don't know. Anywho, it just presses against a screw head that has a crimp on it that goes over to the battery. Yeah, it actually goes over on this side, and then there's another wire that goes over to the charging pin, so that's how it gets the positive wire. Battery, it's most of the iron, and it's decently heavy, so like good quality, hopefully. Must be recycled to dispose of properly. 2.4 volts, 1,300 milliamp hours. You can see it's 2 cells, and they heat shrink it and then add this sticker on top. There is a fuse, which is a fuse wire that just goes over to here. So that's one thing that might blow if there is some kind of fall. If you accidentally touch the end of here, it's slightly recessed, so you shouldn't be able to do that. But if you accidentally got a screwdriver and shorted that, that'll blow that fuse wire. You can replace the fuse wire. They sell wire, or it says just replace with 28 gauge 5/8 long tin copper wire. So that's really good. They intend you to fix this. That is a really good sign. The other terminal just screws down and connects over that short length of fuse wire there. And yeah, and there's another finger that's formed and cut out of the metal strip there that touches the LED. And yeah, and they use pretty decently thick solid core wire to go between this end that touches the negative end of the battery that goes all the way up here to the tip. And the tip itself, the contacts for the tip, they look like cast, some kind of cast metal, and they're pretty beefy. So yeah, and this doesn't feel or look like a normal thermoplastic, so obviously you wouldn't want, if something is heating up quite hot, you don't want it in plastic that gets very soft at low temperatures, because that would be pretty silly. But yeah, and I can just about see the tapped holes for the screws on the other side there, because they said, yeah, I can see the wires when you insert them. Huh, interesting. Anywho, I'm going to put this back together, and let's look at the charging base. You might have to be kind of careful when putting this back together so that these seat properly and they don't touch. There's a divider in the plastic molding. we go. Let's grab the base and take a look at that. So the thing that I love, the charging contacts are just pins, and they're just bent, folded pieces of like spring steel in here. That should be very easy to make, like using tin snips and 3D printed parts. And that's like fairly, it's not super high current, so you don't need to, like, probably regular 3D printed plastic can survive, like, if there is any increase in heat from charging. So I should be able to 3D print an entire dock that I can make my own spring contacts, put them in, and then build some circuitry. Maybe I might also have like a small voltmeter in that so that you can see how charged it is. That'd be pretty cool. We just have the cardboard that slides into these little fingers in here, so we probably pull out from the back, pull forward, yep. And it's decently thick it's like cardboard. Feels a little beefier, so it's probably something a little more substantial than regular cardboard. But yeah, you can see here just how simple it is. It's just metal contacts that are probably stamp formed, and they just bend it into shape and then just apply them there. And when you insert the they flex just a little bit and they touch the ends of these contacts. That's very simple but very effective. Those aren't going to break anytime soon. We have a single transformer that just sort of floats. It's not even screwed down. It's friction fitted when you insert this plate that just presses on here. There are just 2 wires going in, 2 wires going out, but this is charged with DC. It's half rectified. So Big Clive did a teardown. He didn't destroy the transformer, but just opened up the outer insulation, and there's a single diode on one of these wires, so it basically halfway rectifies while it charges this. But yeah, this will charge just fine off DC, just pure DC, so USB should be absolutely no trouble. And yeah, there's just wire nuts in here. Everything is just sort of laid in. It's actually pretty interesting. There's like a 2 notches cut in there, in the molding. I wonder why. But yeah, very simplistic. I probably will do the LED mod to this one just so that I know when it's charging. That would be nice, but not super necessary. And also, I definitely will make my own dock for this because I want to be able to use this out in the field without having to carry this AC adapter around. I love this already. Not quite the same market as like the TS80. This is definitely like heavier duty than something like that. And the fact that you could just in the morning set this to charge overnight, just leave this always plugged in to charge, and then take this out and then just take this with you. If you're not going to do more than like whatever the 120 solder joints it quoted for a full charge, you should be able to just throw this in the bag and just take this and bring it home and put it back on charge. But yeah, like I said, I really want to kind of design like a micro dock or something. I wonder if like the batteries are magnetic enough that yeah, they are. So I might be able to put magnets in the print. Oh yeah, and definitely this screw hole is. So I probably can put a magnet in the print so that it self-locates, and the charging dock sort of magnetically sticks to that. That's a cool idea. Hopefully you guys enjoyed this video. Once again, huge thanks to Isotip for sending this guy, and no expectation for me making a video or plugging their products. So I've heard they've been doing this. Apparently, that's how Clive got his. They offered to send him one for free as well. And yeah, like not a lot of companies that like really stand behind their products and just give out to thank fellow makers in like the electronics hobbyist space. Thank them for their hard work by just rewarding them with a really well-made portable soldering iron. I will definitely get a lot of use out of this. So once again, huge thanks to Isotip for sending this guy in for review. I'm already very excited about designing stuff around this to make up my portable soldering iron kit sort of thing. Anywho, I've rambled on for long enough, so I'll see you in the next one. Bye.